right, today we are continuing with probability. Remember, our big idea is that knowing about probability helps us to compare events, to solve problems, and to understand the real world. Our concept today is demonstrating an understanding of how to use words to describe the likelihood of an event, and today we're focusing on experiments to determine probability. All right. Taking a counter from a bag is what we would consider an experiment. Susan and Marius are conducting this experiment. Susan puts these tiles into a paper bag. She puts 6 red, 2 black, 1 yellow, and 1 blue. Without looking, Marius takes a tile from the bag. Susan records the color of the tile in a tally chart. Marius returns the tile to the bag, and this experiment is conducted 100 times. She says that Marius is more likely to take a red tile than a blue tile because there are more red tiles than blue tiles in the bag. All right, so let's take a quick look at their results. All right, so in their results, they end up having a total of 62 red tiles. So 6 out of the 10 tiles are red, so it is more likely that red is taken. That is what they found in the results, that there were 62 of them that were taken. There were only 18 that were black, and that again makes sense. There's not that many black, there's only 2. Only 1 tile was yellow, so it's less likely that yellow is taken. There are quite a few less yellow tiles. There's only 9 compared to the 62 red and the 18 black. There's 1 yellow tile and 1 blue tile, so taking yellow and blue are equally likely. 9 and 11, the 2 color numbers that we have for yellow and blue, are fairly close, so they are almost equally likely. All the tiles are colored, so we know that there is going to be a color for sure. It is certain that a colored tile is taken. All of the 100 tiles were colored, so that is also proven. There's no green in the bag, so it's impossible to take a green. That is also shown in our results. We have no green tiles taken. All right, now you get to practice. You are going to place 10 red tiles, 5 green tiles, and 5 blue tiles in a paper bag. You will pull out 1 tile and replace it 20 times. So by replacing it, that tile still has an opportunity to be chosen. Now, if you don't have tiles, you are more than welcome to make them out of paper. Just ensure that those tiles are about the same, or those pieces of paper are about the same size. Before you begin, which color of tile are you most likely to pull? So based on what we know here, what do you think will most likely be pulled? Pause and take a moment to think about that. Discuss it with your partner if you have one. Okay, what color are you most likely to pull? Well, probably you would have come up with red, or you should have come up with red. There are more reds tiles in the bag, so it's likely that that's going to be pulled most often. Which colors are equally likely to be pulled? Turn and talk to your elbow partner or your partner and discuss that with them, or think about it for a moment. Press pause and do that now. All right, what colors are equally likely to be pulled? Well, we have 5 green tiles and we have 5 blue tiles, the equal amounts of those, so they are equally likely to be pulled. At this point, you're going to pause and you're going to conduct the experiment. You're going to place all of these tiles into your brown paper bag. You are going to pull 1 out, replace it, pull 1 out, replace it. Do that 20 times, making sure that you record your results. All right, at this point, we're going to watch the experiment be conducted and see what happens. All right, today we're going to do our experiment on probability. Inside the paper bag, we have 10 red, 5
greens, and 5 blues.
Perfect. Now, what did we have to make sure we did when we made our markers? Because we didn't have any. What did we have to make sure we did when we made our tiles?
Make them the same size.
Why do you think that's important? when you're reaching in the bag and pulling out one, why is it important for them all to be the same size?
So then you don't like know which one's like which color.
Exactly. All right, so 20 times we're going to pull out a piece of paper. I'm keeping track?
Yes.
Okay. All right. So we have possibilities, we have what? What are our possible outcomes we can get? When you put your hand in and you pull out, what can you get?
Of what?
Of colors.
You can get 10 reds.
No, we can just get red, no number with it. And we can get
Blue.
yep. And we can get
Green.
green. Those are our possible outcomes. This is what we can get. So I've put them onto a table and we're going to keep track of the colors that we pull. Now every time you pull a color, we mark it down and you put it back into the bag. Why do you put it back into the bag, do you think?
So then you can pick it again?
Yeah, so you can pick it in. Exactly. All right, start. 1.
Green.
Okay, put it back in. Mix them up a touch. Okay, again.
Blue.
Okay.
I got 2. Blue again.
Okay.
Red.
Okay.
Blue.
Okay. That's 5. We're a quarter of the way through.
Ah. Green.
Okay.
Green again.
Okay.
Blue.
Okay.
I'll try to get some reds here. Oh, red. And green.
That's halfway.
And reds haven't got very much, but that's the most of them.
And I know, that's unusual, isn't it?
Green again.
Mm-hmm. It's very unusual.
Do you know a trick?
I don't know a trick. Do you know a trick?
No.
Is there any way you can make sure you pull a certain color?
No.
No.
Unless I look in the bag,
Yeah.
that would be cheating.
Exactly.
Oh, dang, I dropped it. Red.
Red.
Right now, greens have the most.
Yep, right now greens do have the most.
Green again.
Another green. Oh my goodness.
Here is blue.
Blue. Okay.
And another blue. Blue again.
Mm-hmm. I can't believe we don't have more reds. That's crazy.
We only have 3.
That's crazy.
Red.
Yay. Those poor reds. They were supposed to be the winners, and they're not.
Green, green and blue are tied.
Green and blue are tied.
Blue, blues in the lead.
And you only have one more pick. Oh, 2. Put them back in and try again. That one doesn't count.
Make sure I have one this time. Green.
Okay, so just to be sure that everybody knows that we really did have red in there, can you dump out those things? Right, okay, and we can see there's lots of R's, right? Can you flip some of those over for me?
Yeah, let me just...
So what we ended up with while she's flipping, we ended up with blue most often, green second most often, and red least often, or unlikely. what we should probably have ended up with, or what you would think we would end up with based on what we have there, is so unusual that we ended up with that many reds.
That many green.
Sorry, that many greens and that few reds, right?
Yeah.
Because looking at this, what should we have ended up with the most of?
The reds. I even thought we were supposed to have most reds.
That's right. And we probably should have, like probability, using probability, we should have ended up with mostly reds. But sometimes that doesn't always work out. It just means that's what's most likely, but that doesn't mean that's what's going to happen. And that's what happened today, right?
Yeah.
Yeah. All right, so as you can see, with probability, we can use it to predict what's going to happen, what is most likely to occur, what is least likely to occur, what is equally likely to occur. But once the experiment is actually conducted, that may not be what actually takes place. It's just a predictor. It can predict what is going to likely occur, but not necessarily what actually happens. So when we compare our results to what actually occurred there, then we can see that no, our results didn't go with our experiment, or our results from our experiment didn't go with what we thought would happen. We would have expected red to be most often. We did not end up with red occurring most often.